Hey guys, it's me again. We are now going to try this the second time with 5.1 relating graphs to events. So let's go, shall we? There's 3 things you need to know about relating graphs to events. You need to know how to interpret graphs, how to sketch graphs, and how to relate graphs to other situations. First, let's look at interpreting graphs. Right here we have an example of a commute. One student walks and takes a bus to get from school to home each day. The graph at the right, and in case you're wondering which one the right is, it's right there. Anyway, the graph to the right shows the student's commute by relating the time the student spends commuting and the distance he travels. So we have time here. Trying to draw my little arrow. And we have total distance here. Describe what the graph shows by labeling each part. Now right here we have the first arrow, and it's saying that's where the person is walking. The distance is increasing slowly. And then we have this little stagnant line, no movement whatsoever. And that's when the kid is waiting for the bus. Then all of a sudden the line takes off up here. And it's when he's actually taking the bus, and it's the distance increasing quickly. And then it goes back to slow. So now he's walking again. So he's walked to the bus, taken the bus, and walks home. So you see it goes a little bit for walking, no movement at all for waiting, quickly for the bus, and then a little bit again for walking home. Let's look at the next page, guys. Now we've got sketching the graph. This example is about travel. It says a plane is flying from New York to London. Sketch a graph of the plane's altitude during the flight. Label each section, not selection. I don't know what I'm trying to say, guys. Alright, so if you look up here, this bottom half is about time. This top part is your altitude. Right here is where the plane is taking off in New York. Then right here at the crest, it starts going straight again. And it's when it's hit its top altitude, and it's just going to keep going the same height all the way across. Remember, this is still how long it takes to get over there. Then it starts coming down. Now right here, it's where it's circling, waiting for a runway, because sometimes you'll have more than one plane come in at the same time. So you have to circle around a couple of times waiting for somebody to take off so you can land. And you don't exactly have to put that part there, because not all planes have to do it at each time. But then you have the actual descent, the landing in London. So that's how you sketch a graph and list things. So let's try one together, guys. This one is sketch a graph of the distance from a child's feet to the ground as the child jumps rope. Label each section. I'm going to get my handy dandy Mimeo tablet. And I'm going to get my notes out, because I like making sure I'm doing it right when I do this for you. Okay, so I'm going to change over from highlighter to pen. Let's use red. Alright. So we have this bottom part here is going to be our time. Miss Kelly's making faces at me, guys. Alright, anyway. So it's a sketch a graph of the distance from a child's feet to the ground as it jumps rope. Label each section. So I'm going to come up here. I'm going to jump and land, and jump and land, and jump and land, and jump and land. Not the prettiest of loops, I promise you, but I tried. Now, what do you think this right here, this line is? That's the height that that person got. I got a random dot again. Trying to write sideways. Have you ever tried to write sideways on a tablet, guys? Kind of awkward. Every time I hear the word awkward, all I can think of is Danae on the bus from the mountain trip when stuff was going on in that movie, She's the Man. Everybody would get quiet and finally you'd hear awkward from Danae. You know you did it like 3 times, at least. 12. Okay. So we've got the height that the person jumped, and we have the time that the person jumped, how long it took them to jump. Alright, so right here, let me choose a different color. I'm going back to blue. These spots here, this is where the child landed. And then here, 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 and here, this is where the child jumped. Or you could say where he cleared the rope. Cleared the rope. Because remember, when you're doing the whole jump rope thing, when you're up in the air, the jump rope goes under your feet. So he's clearing the rope. If he hadn't, the little loopies would not have been going so smoothly. There would have been some kind of picture of him tripping. Don't ask me to draw that. You see how well I drew loopy thingies. Let's not go there. Alright, so the next page. Alright, this time we're going to look at relating graphs to situations. We have a multiple choice question. Don't get freaked out. Suppose you pour water into the container at a steady rate. Which graph shows the change in the height of the liquid in the container over time? Now, steady rate is when you pour at an equal rate. You're not going to pour really fast or do a little bit, then tip a little more, then pull back, and then tip a little more. It's just steady. If you look at these, we'll stick with blue because we got little water droplets coming in here as I press a button and lose my pen. Okay, so water's coming into this bowl here. And I did it again. How do I get back? There we go. Alright, I want you to notice the shape of the bowl. It's smaller here and wider up here. So it's going to get fuller faster down in this area. And then as it goes up and spreads out, it's going to get slower. So right here, it tells you that the rate of the water, or that the water rises, will decrease steadily because the container gets wider from bottom to top. So A is the correct answer. Because it's like really fast and then starts slowing down as it gets higher because it's spreading out. So it's not going to get as high. Look at this one. It's like, meow. You know? Filling it water's not going to do this unless your bowl's like little, wide, little again. And that bowl's not shaped like a weird vase. Then you've got this one over here. Bloop. That's if it's the same size all the way up. And then this one goes whoop. That would be if you start out with a wider bottom and start getting smaller going up. One of those weird, like, triangular looking vases. I don't have one of those, do you? No. How do you put a flower in there? I don't get that. Anyway, so A is your correct answer. Woo! Well, I guess I should have filled that in since you fill in bubbles, huh? Alright, let's go on to the next page, guys. Alright, a car travels at a steady speed. Which graph could you use to show the speed of the car, and which could you show or use to show the distance traveled? Explain. Alright, so we're looking at steady speed. Steady speed. Which graph could you use to show the speed of the car and the distance traveled? Well, it says steady speed. Means the speed doesn't change. So this one, writing sideways again, this is not fun. This is your speed. Because it's constant. It's steady. This one here goes up, like that. There's a better line there. And I actually drew these little graphs and lines on paint for you, so you'd be able to see what it is, because you see how badly I draw. Anyway, this one's going to be your distance. I'm just going to stop there because I'm running out of room for the word distance. See how it goes up? Steady doesn't go up, so it couldn't be your speed. This one will show your distance. You started here, and you went all the way over there. This one could show distance from here to here, but we're not really going up anywhere. I mean, I guess... Okay, it really wouldn't show you distance. I'm losing my mind, guys. This one would be like that bus a minute ago, where the kid was waiting for it to come, and it's stagnant and not going anywhere, just standing there. So this one will not show speed, or show distance. This one here shows distance. Woohoo! Yay, D! Alright guys, that's the end of 5.1. I hope you understood it. Sorry about the little mix-up at the end. I know Parker's sitting there going, yet another mistake! If you're not in Parker's class. Parker likes to point out when I make mistakes on the board. There was one right there. So, ha, Parker, I beat you to it. I told everybody about my mistake. Anyway, time for 5.2, guys. So go ahead, finish taking your notes, and click on the next video. See you soon.